Hi everyone. So today we will be solving LeetCode 1967. This is today's POTD and it's a very easy problem. So I think we will not have any difficulty understanding this. So coming to the question, we are given an array of strings, patterns, and a string word. So there are two things given to us, an array of strings and the string word. We need to return the number of strings and patterns that exist as a substring in word. So what we need to do? The word is our main string, and these patterns are a collection of strings, and we need to check how many of them from this array are substrings of this word. Like for example, in the first example, we have patterns is A, B. Let me erase it. So in the first example, as you can see, we have patterns is something like A, ABC, BC, and D. And our word is ABC. So let's look at the first, pattern. So we have A. We need to check A is a substring of this or not. So as you can see, A is a substring. So that's why this is a valid one. So we count it. Now coming to ABC. So we need to check whether ABC is a substring of the given word or not. So ABC does exist, so it's also a substring. So this is also a valid substring. Coming to the next, we get BC. So we would check whether BC is there or not. And as you can see, BC is here present in the string. So this is also a valid substring. Coming to the D, D here is there is no D here, so that's why this is not a valid substring. So our valid substrings are A, ABC, and BC. So we return 3. See, substring is nothing but a contiguous portion of the string. Suppose our string is A, B, C, D, E. So this can be a substring, AB can be a, BC can be a substring, or simply a D can be a substring, or the whole string is also a substring of itself. So A, B, C, D, E is also a substring of itself. So I hope and suppose there is AD. This is not a substring because it is not contiguous, right? A is here, and after that, two positions after that, we have D. So it should be continuous. Had it been A, D, C, D, E, suppose, had the string been this, then AD would have been a substring. So I hope it's clear. The substring should be contiguous in nature. Also, coming to the second example, we have the first pattern is apt. So we check in the word. Do we have it? Yes, we have it here. So we count. We would take a count variable initially assigned to 0. So we found app, so count is increased to 1. Then we go to the next, we get CD. CD is not present here in the word, as you can see. So we do nothing and move forward. Then we get IKC. IK is here, but C is missing. So this is also not a valid substring. Then we move to E, and as you can see, E is present here. So this is also a valid substring. So count increases to 2. That's why 2 is our output. So I hope the question is clear. So let me jump to the code directly because this is a very simple problem. So coming to the code. So as you can see, we need to return an integer. That is the count of substrings we have in our patterns. We take patterns array as input and word as input. So we take initially a counter count, initially initialized to 0. And we check all the strings present in the patterns array, and we use this function. This is a string function, and don't worry, I will be making a video on all the string functions that are most widely used so that we could get a clear understanding of them also. So for now, I'm just telling in short. So The contains function does nothing, but it only checks whether a string is present in a main string or not. Suppose we have something like s1 dot contains s2. So what it does is it checks whether s2 string is present in s1 string or not. That is, it checks whether s2 is a substring of s1 in simple words. I can show you an example also. Suppose we have A, D, E, F, C, and S2 is D, E. So if we call this S1 dot contains S2, so it would check whether this S2 that is DE is present in S1. So we can see here this is indeed present in S1, so it returns true. Suppose our S2 was something like uh, K, J, then we would check it's not there in this substring, so we would have returned false in that case. So I hope this is clear. So we just check if this function returns true means our string that is from patterns array is a substring of the given word. So we increase the counter by 1. And finally, after processing all the strings, we return the count. So this is the entire approach coming to the time and space complexity. Since we are traversing the entire patterns array, so time complexity becomes big O of n, where n is length of the patterns array. And space complexity, we are not using any additional space apart from this just a single variable. So space complexity is constant, that is big O of 1. So this is the time and space complexity of our approach. So I hope you got this question. And next I will be making the video on string functions so that we can have a clear understanding of them as well. So yeah, this was it for today's video. Thank you so much for watching.